Yeah, this is the 1-bit encoding for the string class, and in order to do 1-bit encoding, we set the function pointer to take every bit we send it and then encode it in a single bit in the entire array. First of all, when creating the 1-bit, we have to allocate the buffer size is the capacity, the total size of the string, divided by 8 plus 1. The reason that we have plus 1 is so that when there's always a remainder. If we divide by a number that's not easily divisible by 8, there's always going to be an extra cell bit, so we add one extra byte. So we allocate as usual, but we add one extra byte to one extra byte to take up all the remaining bits. Okay, in order to set the bits, we take the original value that's equal to the original value, or it to the value that we are adding, the bit we are adding, and 1. So we only takes the last bit of the value that we get sent. We always take a 32-bit value, but it only takes the first bit, and we shift it left by 7 minus the index modulo 8. So here the reason that it's n7 is because we're taking the last 3 bits. So if we're dividing by 10 and if you divide a number by 10 and you just want the remainder, so you just take the remainder is always going to be the last digit. If you're dividing by 100, it's always the last 2 digits, the remainder. So we just take the last 3 bits, right? The last 3 bits right here. That's the remainder of whatever number we give it, the index divided by 8, whatever the remainder is, and you shift it left 7 minus you shift it left by 7 minus the number, the 7 minus the remainder, and then you take the bit at the position and owe it to the original bit. You find the position here divided by index divided by the position, and it's the remainder of index divided by 8, and you just set the bit. To get the bit, you just do the same thing. And the index divided by 8, shift it right by by 7 minus the remainder of index divided by 8, and just end it to 1 just to make sure that you only have the last bit. That's pretty much it for this part. Okay, to test it, we have the bit string, and then we create a string. First of all, we create this string in 8-bit, just a normal string in 8-bit, and then we just set it up here, and then we cheat a bit, and we cheat by setting everything to 1-bit, and multiply the capacity by 8 and the length of the string by 8. So we just set everything to be 8 times bigger than it is. But that doesn't matter so long as in the string the size is the total number of bytes, but the capacity and the length represented the number of characters, which is not the same as the number of bytes, especially now that we're using just 1 bit. Okay, we set everything to be 8 times bigger, and we set the function pointer to be index 01 to set for the 1 bit as opposed to 8-bit and 16-bit and whatever. And then to print the screen, we go to every bit. We get we get the character at that index. If the character is a 1, we output a 1 in the buffer. We output a 1. If it's a 0, we output a 0. We can't just print the string with 1s and 0s, because a 0 means that we can't print anything. That the 0 means the end of the line character. So we just print it, and then the result. Okay, this is supposed to share 1-bit string, and then this is the 1-bit equivalent of that string. Take that string, make it 1 bit of the size, and then print it, and it looks like this. Each 8-bit represents 1 character here in ASCII, and that's it.